Adam, Chalupe, Awa, Tom, Mohammed, Chloe, Dominic, Lewis, Chris, Ali, Latia, Katie, Kelsey, Alyssa, Hannah, Ali, Imogen, Isabella, Malachi, Regati, Kumar, Millie, Luke,
Yes, sir.
Mohammed, Katie, Oliver, Mia, Lawrence,
Yes, sir.
Shanice. Okay, thank you. We've got 10 not here, and we've got 4 on the call. Oops. Okay, did we end up drawing the cell cycle last time? Is that how we worked at the cell cycle? Okay. All right. I'm going to choose Mia. All right. Describe 3 genetic diseases, please, as much as you possibly can.
And then there's Down syndrome, which is like a disease that affects chromosome 21, and it's like small features like overdrive and small nerves and that.
Okay.
And then there's cystic fibrosis, which is like where the mucus is like sticky, and then it can cause like it can affect your lungs and damage your lungs.
Okay. Any more facts about any of them?
Makes the development can be like blood digest. Two people diabetes that actually be born with it.
Okay.
That's meningitis syndrome. Nutritional hormone that is typically on the X chromosome of the X chromosomes that missing.
Okay. Right. What chromosome was Turner syndrome on?
Is that what it's called?
So on the X chromosome. What was Down syndrome? You did say it before. And what was cystic fibrosis? You didn't write that down.
7.
Yeah, chromosome 7. Right, so what it is, it's a dodgy gene on chromosome 7. That was dead good, right? And what you did is you went through them all, then you went back, right? You kept on remembering stuff. Right, just got to remember, when you're doing a question like this, you've got to get all the facts for one, and the facts for the other, and the facts for the other. And it's hard. I realise it's actually hard. I'm now going to choose, who should I choose this time? I'm going to choose Malachi. Right, describe those 3 genetic diseases, please.
Just like you did.
Just like you did.
So there's one.
No.
So there's Turner syndrome.
Yep.
And that's in 1 in every 2 genes. So
I won't worry about the numbers too much. It's more about the symptoms, the treatments and stuff like that.
it occurs in women. Number 7.
My brain freeze now, Kai. Alyssa, do you want to do all of them? Well, just do Turner syndrome then.
It goes in the X group.
X chromosome, yeah.
It affects those.
Yep.
That's it.
That's it. Symptoms.
It starts off from like you growing and
Yeah, 4'8", approximate average.
and you guys are like
A big neck, wide neck, right? That's kind of the thing. Go on.
But it also makes what they call
Big bones. Yeah, weak bones as well. Okay. You need to know, right? Just like Mia said right at the start, you pretty much got all of it, right? If you get a written question like that, Rick will usually be able to hammer it out all the time, right? Now, what we've then talked about, the genetic diseases, right? Is we've talked about all the genetic diseases, right? And we've just started to go through the cell cycle. Now, I understand that what I forget, get that day off and I forget everything. Right? Now, I think what we did is we drew this at the very, very end of the lesson, right? Has anybody didn't finish drawing it? Okay, I think pretty much almost everybody did. You didn't finish drawing it, or you weren't here?
Oh, no.
Right. Now, what I'm going to do now is I'm just going to explain exactly what the cell cycle actually shows. Right, then, following on from the diagram that you've actually got, right, what I'm going to want you to do in your own words is describe the cell cycle. What it does, it starts here, right? And if you imagine that can be any cell anywhere, right? It can be anything, right? So let's say it's a skin cell. What that skin cell does, it goes through a phase called interphase. That interphase is growth. Right, so basically what you'll do is at the start of interphase you'll have a cell that big, and literally what it does, it just gradually gets bigger and bigger and bigger and bigger until it's pretty much twice the size, which gets to here. Then what happens is it's nuclear division. So you've got your little nucleus in the middle there. I'll draw these a bit bigger so it's a bit clearer. Right, so what you've got is you've got your cell with the nucleus in the middle. Interphase, the whole cell then gets bigger, but the nucleus tends to not be affected quite the same. When it gets to mitosis, or mitotic division, this is then when the nucleus then increases in size, and it gets twice as big. What do you think then happens here? Again?
Tending to a specific cell.
Yeah, so let's say it's a skin cell there, gets bigger, 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 it gets to there, then what it does is the nucleus then gets bigger, 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 and it gets to here, so now the whole cell is bigger, the nucleus is bigger. What's the whole cell going to do now? Split, right? So what it does then, it splits down the middle, and then what you've got is you've got two cells that look exactly the same as that. Okay, so in your words, right, what I want you to do is you don't have to write bigger, 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 bigger too many times, all right? Starting here, right, using as much scientific terminology as you can, I want you to write down what the cell cycle means. Chris?
So you know when it gets to the mitotic phase?
Yeah.
What happens then?
So that is then when the chromosomes then, this is basically all the boring bits in the cell, right, where they get bigger. When it gets to here, that's when the chromosomes then start to expand, get bigger, right? And then they divide here, all right? So I'll just sort of say it scientifically. You start off with one skin cell. The cells grow, which is then all the cytoplasm, the cell membranes, the ribosomes, the mitochondria, they all grow and multiply. That's your interphase. The second one, right? As soon as it gets to the end of the interphase, this is then when mitosis happens, which is where you get nuclear division. Right? So nuclear division is when the nucleus itself starts to grow and develop and start to multiply. Then the whole thing splits, and then you make two new, exactly the same cells. Tom?
should we do all the subtypes?
Yeah, just do a little subcycle and then just kind of explain it into your words. And then what I'm going to do is I'll just choose somebody just to explain back to me. You all right, Ali?
Yeah.
You need something? No?
Oh, no.
Oh, okay, all right, that's fine, Ali, that's fine. No, the TA. Right, you just judge it during the lesson. Lawrence?
Does that happen in every cell?
Every cell, except for,
Red blood cell.
no, yeah, red blood cells are slightly different. It only really does this.
Red cells and
Brilliant. Absolutely brilliant. Well done, Lawrence.
The nucleus grows and what?
The nucleus grows.
Yeah,
The nucleus grows here,
yeah.
and then it divides. And in a minute, or the next few slides, it's all about this phase here. right? We're going to go through exactly what happens step by step in this bit here in a minute, right? And they will ask you what mitosis is. So it starts with one cell. That one cell grows, cell growth. The cell grows and grows. All the little bits inside it, the mitochondria double up, the ribosomes double up, the cell membrane gets twice as big. Right? Everything increases in size. When it gets to mitosis is then when the chromosomes start to replicate and divide. Then the entire cell, at this point here, cytoplasmic division, the entire cell then splits, and you've got two daughter cells. Two daughter cells. So look like girls. Yeah.
You know what are all both? What's that called again?
Here?
Yeah.
That's interphase.
No, it begins with an N, you said.
Oh, nuclear division. Okay, so it's nuclear, the nucleus dividing. And this whole cell cycle, or this ending of cell cycle, has happened about 250,000 times by the time you've walked in and by the time you leave. Like that end bit has happened, the whole cycle hasn't, like just the end bit. Yep. When the nucleus splits, it's called mitotic phase or mitosis. But in a minute, what I'm going to do is I'm going to go through all the stages that happen in that. Okay? Yep.
It will stop once you get wanted.
It'll start that, sorry.
It will stop once you get wanted.
It does actually carry on for a little bit, actually. Right? So even when people do die, then cells do continue to grow a little bit until all the glucose and all the different chemicals and enzymes have sort of denatured. They do, I don't know how true it is, but they do say that people's hair continues to grow for a while. Right? Once they're actually dead. I have no idea. I've never measured anybody's hair. In 21 years, one day a week. Right? Wednesday, 21 years.
Okay.
Yeah, which Wednesday? December in 21 years. Can you just text me the day after just to make sure that you're still alive? Just to prove that it's actually available. Yes.
What's the
Cytoplasmic, right? If you think about it, you've got a cell, right? And most of this here is the cytoplasm. That's where the mitochondria and the ribosomes. Cytoplasmic division is when it splits. So it's the cytoplasm dividing into two. Okay? Right, another minute on this. And I'm going to go through mitosis itself. Okay. Right, on three, nobody talks. Tom, can you explain this to me, please?
So there's a cell, and it goes through interface, which is all of it, like, yeah. Which is all the cells and all the genetic development. Then when we get to the mitosis, then the nuclear states not be gone. As it gets to the cytoplasmic division, the full cell divides into two pieces.
Okay. two pieces, and that's usually called a parent cell. The very first cell is a parent cell. It goes all the way around this, where you make two daughter cells. You know, those two daughter cells, what they will then do the same thing. What they will do is they will then reproduce as well. Right, but you also got to think that there's lots of cells dying at the same time. Right, now, what I'm going to do now is I'm going to go through mitosis. Right, now, with the cell division that we just had on screen there then, right, they might ask you what interphase is, they might ask you what mitosis is. If they're going to ask anything about the cell replication cycle, it's going to be to do with mitosis. Right, and what I'm going to do is I'm going to show you 3 versions, right, of mitosis, and then the last version is then the one that I'm going to want you to write down because it's kind of the one that they've got on the exam. So, start off with one cell. Inside that cell, right, so let's say it's one of my skin cells, there's 2 chromosomes, right? Macy, how many chromosomes should there be in there if it's one of my skin cells? 46. There should be 46, and they don't put 46 in there because it'd be an absolute nightmare to draw it. The first stage, which is then your interphase, right, or end of interphase, what happens is the cell chromosomes duplicate. So that red one becomes 2, that blue one then becomes 2. Then what happens, the cell here, I mean really what they should have done on this, they should have made the cell a lot bigger. Then what happens is a red and a blue go that way, a red and a blue go that way. Then the cell comes in and you've made 2 cells. Chris, what can you tell me about that cell and that cell?
Is the starting cell the same as how it ends?
Exactly, they're identical. Parent cell, double the chromosomes, double in size, splits down the middle, 2 daughter cells made. A slightly more complicated version of it is where I just put 4 in. But the process then is exactly the same. Okay, so this time I start with 4. You do know anybody that's talking and messing around is going to get asked millions of questions, don't you? 4 chromosomes, big one and a little one. Everything doubles, which is like your interphase. Then it starts to split, which is kind of end of your mitosis phase. 2 cells. Lawrence, what can you tell me about that cell and that cell? They're the same, they're identical. I didn't want you to tell him. Okay, Luke?
Do you know is it Down syndrome, does one of these not separate properly?
Yeah, so what happens in Down syndrome, it's sort of, you've got 4 there, and what happens is for that one chromosome itself, 3 of them will go, or you'll get an extra one that goes up during this phase. But it only happens very, very, very early on. Lawrence?
How did like scientists find all this outside? How?
Funny enough, I mean, this here, if I just show you the pictures, right? Now, a lot of science is pure guesswork. Right? We can't look at atoms and elements and stuff like that. We're just kind of working out the idea that the fact that they're there. But with this, we can actually see it, right? Where this here, I'm sure I've shown you this. Haven't I? Right? What this is, that is the nucleus of a cell. And what it's doing is all the chromosomes and stuff like that. So you've got 46 in it now, right? Every single little cell in your body, right? This is obviously time lapse, right? Every single cell in your body is doing this. And what they're actually doing there is the DNA in one of your cells at the moment is a big long line, right? When it gets to the mitosis, what it does, it squashes up. So it starts off on a big long line like that, and you can't really see it. When it gets to mitosis, what it does, it squashes up, and it becomes a little fat line. It kind of coils itself up. And that's basically what's happening there. Okay? And then, what they're actually starting to do is they're starting to duplicate themselves. Then what they do is, and I have to admit, I think it's absolutely incredible what they actually do, is they actually line up. They literally line up inside the middle of the nucleus, ready for one half to go that way and one half to go that way. So you're talking about tiny, tiny, tiny little things inside the nucleus of a cell. And then what they do is they literally split. Right? So Lawrence asking that question there, how do we know? We can actually see it.
So 23 or 1 and 23 go deeper.
Yeah,
Can I cancel?
okay. And then what happens is, then what you've got then is you've got your cell. I don't think this one particularly shows it as well, but there it is again, right? So what you got this time is, they're all lining up. Okay, this is happening obviously very, very fast on there. Okay, and then at some point, there, the last one, there was one over this side here, it wasn't there, right? They've lined up, and then they split. And that is literally what is happening, which to me is absolutely incredible. Yeah.
If 24 went one way and 22 went the other, that means it's wrong.
It'd be something wrong, but the cell would die.
Oh,
Most likely the cell would die. Okay, so if ever there's like a faulty cell, right, the body will then just reject it and it will just kill it off. Okay. Yeah.
So do you know like with the things like running that way and that one running that way?
Yeah.
If one extra runs that way, will that cell die?
Both of them will die. Right. Because if you think every single one of your cells has got 23 chromosomes, right? So if one had 22 and one had 24, it's abnormal, right? So the chances are it probably just died. Right.
What is alive? What will it create?
It'd be a mutation of some sort, right? And it could be the leading of cancer, right? It could be the leading into something like that, right? But vast majority ever will just die. Just like if I bombarded everybody in here with radiation, right? What would happen is a load of your cells would malfunction, right? But the chances are the vast majority would die.
What's radiation?
Just like nuclear radiation, so from atomic bombs, uranium, right? Sunbeds is a form of radiation. Yeah. Is it normal for cells to die? No, the vast majority of cells will just keep on doing that over and over and over again, right? Until they get to the Hayflick's limit, right? And the Hayflick's limit is then the point at which they can't do it anymore, where they've kind of got enough. Yeah.
but isn't like X-ray, like radiation?
Yeah, X-rays can cause issues, right? Now, if you were unlucky and you actually had an X-ray, it could cause cancer in one of your cells, right? But then the chance of that actually happening is incredibly low, right? So it's risk against benefit. So if you're going to get an X-ray that is then going to solve something for you, it's worth doing on the 1 in a billion chance that you might get it. Yeah.
What's the small percent?
What's the end called?
And now when we've got the two big cells, we've got two big cells, so what then was?
Hold on a sec. Pop on here.
We've got a black.
Oh, did you? How lovely. Thank you. What should I in it?
Yeah, sorry.
You talking about this one and that one? First one is the parent cell, and then the one at the end is then the daughter cell. All right, and then as soon as the daughter cell's then been made like that, what the daughter then does comes into a parent, right, and then it becomes a parent, and then it starts to do exactly the same thing again. Yeah.
Say you lost like 4 chromosomes, you die.
Where have you lost the 4 chromosomes from? Right, if you think, right, you've got
Say 20 went one side, and then 26 went the other, and they died, what would happen to you?
right, let me just show you. Right, you've got approximately that number of cells in your body. Right, so if one of your cells goes a bit funny, is it going to make much difference?
Billion, 37 trillion.
Right, 37 trillion or whatever it is, right, if you've got one cell that goes funny, even if 1 million cells go funny, it isn't going to make any difference to you. Right, the only problem is if one of those cells becomes cancerous, right, that is then when you've got an issue. Yeah. I don't know, it's just the terminology for it. Okay.
Sexist.
Yeah, hold on a sec, nobody talks. Yeah.
Do you know that diagram that you had before?
Yeah.
That one there?
Yeah.
What about if it was a boy, would they still do that?
Yeah, exactly the same.
This wouldn't happen all over again.
No, it would. It would. Right, now, the reason why it's called a daughter cell is just terminology. It could be called son cell, it could be called baby. It's called daughter because it's kind of.
Oh, I thought you meant, then that's one parent, that's another parent, they add together, then they make babies.
Oh, right, no. So what you've got is you've got one skin cell, right? It could be male, it could be female, right? And what I could do is I could then just have X chromosomes and Y chromosomes in there, right? And the whole idea of this is growth, right? So your skin at this moment in time is growing, right? Because what's happening, some of your skin is dying, right? And then some of your skin then needs to come back again. So what happens is one skeletal cell grows by going through this process and making two daughter cells, right? Now, just daughters, nothing to do with sex or anything like that, or gender or anything like that. It's purely just two daughter cells are made. Yeah. Yeah, that's what they do with burns. Oh, come on. Yeah, skin grafting. Right, so literally what they'll do is, so let's say I had a big burn in the face here, right? Then what they do is they'll probably take a little centimetre square of skin off my thigh, then grow it, right? And they grow it reasonably rapidly. And once you've got sort of about that size, what they do then is they somehow fix it onto my face, right? And then and then the hole that they made on my thigh would then heal over naturally. But it doesn't matter if you've got a bit of a scar there. Yeah, I don't know exactly how to do it, but it goes on a bit like sort of tissue. Yeah. Oh, shh. They got what, sorry? Right, that's probably just the way that the skin's grown. I don't think they've actually been able to get it off any other animal. All right, right. This is now, right, the way that they'll show mitosis in an exam, right? This is basically the sort of thing that you'll get out of a textbook. It's the sort of thing that I see in the scheme of work. Okay, now it works exactly the same. What you do here is you start off with a parent cell, 2 red, 2 green. Interphase is when the whole thing then grows. At this point here, we're starting to get to mitosis. So basically, mitosis starts here. The chromosomes double up. So where you've got, that is your DNA normally, one big long line. That is then when it's kind of shortened up at the end of interphase. Then, quite amazingly, what it does, it kind of goes from the middle and it grows, right? That little bit in the middle there, it sort of grows out of it. And it makes this funny little X shape, right? What it's got a line at the top there, line there, line, just basically multiply that. Then what they do is that video that I showed you, they all line up in the middle. However they do it, I've absolutely no idea, but then they line up in the middle. And if you look at that X there, what the X does is, if you think my hands are the X, right? Literally what it does is half goes that way and half goes that way. And it's that little bit in the middle, right, that splits. And when it splits, half goes that way, half goes that way. Then the whole cell then starts to break into 2, and eventually you get 2 daughter cells at the end there. And the daughter cells are identical to that. What does that daughter then cell start to do? Starts interphase. All right, and then what it does, it goes all the way around again. And that's the cell cycle, constantly happening over and over. Lawrence?
What if, like, 2 of the cells were switched, so like, one of the girl cells was on a fight and a fight.
Okay, how many girl cells have you got in you?
0.
0. So therefore, this is never going to happen with a girl or a boy. That'll be a girl cell up there, right, that then divide, and then in you, it'll be a boy cell that then divides. This is literally, the whole process of mitosis is for that cell to replicate itself, so you've got 2 of the same. And that's called growth. Tom?
I'm really like sure the cells going through all phase, those
I was trying to think of that actually. I think it takes days. I'll actually look it up while people are doing something. Lawrence?
You know how you said it'll just be a girl? How, you know when you have twins, how can like one be a boy and one be a girl?
Right. That's got absolutely nothing to do with mitosis that's going on at the moment, right? So you could get twins, right? You can get twins, right, in 2 ways. You can have an egg and a sperm, right? That sperm goes into that egg, fertilizes it, and then for some strange apparent reason, that fertilized egg splits into 2. Okay? And what you've then got is you've got identical twins. It's the same sperm and the same egg, and the egg split into 2, and then you get 2 babies. That's identical twins. To make twins where it's a boy and a girl, you've got 2 eggs, and you've got 2 sperms. All right? Eggs are always female. sperms can be male or female, all right? So if that's a boy one, and that goes into that egg there, you'll get a boy. If that sperm there's a girl, it goes into there, and then you get a girl. So literally, it's 2 eggs and 2 sperms that make normal twins that can be different genders. All right, now, under the title in your exercise book's mitosis, I need you, right, and I want you to use colours, all right? I want you to use colours, and what I want you to do is I want you to do that process as accurately as you possibly can. Tom? Yeah, new classwork and date. To the right of it, what I've done is I've kind of summarised the stages. Now, it's up to you what you want to do, right? You can just write down that there, right, to actually summarise the phases, or you can use your own terminology, okay? But that, mitosis, that version of it is the way that you're going to get asked it. And to me, sorry? Yeah.
I'll just copy that.
You can if you want to just copy that, right? But and I could have just printed it off and given it to you. But if I print it off and give it to you, you just take no notice of it. All right? So what I want you to do, you can just copy that, right? But I want you to think about the actual stages as you're going through. Let's hear it. Right, would you guys just move along then, please? Right, we'll see, you just want to sit here. Luke,
Will there be a high chance of this being in a GCSE test?
will the what, sorry?
Will there be a high chance of this being in a...
Okay, the problem is, Luke, I can never know what's going to be on there.
It's like...
It's likely. Mitosis is a big. If you think about it, it feels complicated, doesn't it? Right? It sounds complicated, but it's actually not.
Yeah.
If you've drawn it and stuff, right, then what you need to do is, obviously I'm going to be asking somebody to describe what mitosis is. Right, you need to think about it as like 5, 6 bullet points. Start with the parent cell, end with the daughter cell, that's 2 parts. How are you going to break it up in the middle, right? Because the whole thing with this, right, and then what Mia did dead well at the start, right, was structure your answers. But structure it, so you just got to get it all right. You can't say, start with the parent cell, end with the daughter cell, and then somewhere in the middle, they line up and they double, right? You've got to structure your last sentence so you can tell me exactly what is happening. Shanice, what's the whole point in this process? Shanice, what's the whole point in this process? Right, and we're being G them after.
Why?
Growth.
Oh,
So the whole point in mitosis is to get two daughter cells, like you say, and what it's doing is going from one parent cell to two daughter cells, which is growth.
Let's do that. I mean,
Growth.
like, it helps you grow
you should have done like that, yeah.
Exactly.
Not like
Yeah.
They could have said monkey or something. Yeah, Malachi.
So like, say if like two parents have a baby, and what if like one of them has like a disease, but the other one has a different disease?
Right, it's all pot luck, right? It's purely, it all depends on what genes go into a sperm and what genes go into an egg, right? So your dad could have the 10 worst genetic diseases ever, and your mum could have the 10 other worst genetic diseases ever. They could have a kid, and that kid could have none of them, right? Or that kid could have 20 of them, right? Which would be unfortunate, right? But that's kind of where it goes. Yep.
Do you know like can two Down people have a baby together?
They can. I was thinking about that, and I think
And will it turn out to be a Down syndrome?
I think it's much more likely that it is. I don't think it's definite.
Because it's like, if two dwarf people, small people have a baby together, that baby's a dwarf, isn't it? Not necessarily.
I can't remember. I'll have to look it up
So
exactly
I
whether it is
always
or not.
see people walking in town with like two parents and a little dwarf baby.
You like that?
Yeah, it's cute.
My sister wants to adopt as well.
Have you seen the tiny door in Blackpool? Thanks for the dwarf was there.
The what?
Have you not seen the house? It's like the door for the height of this table.
But on the big junction,
Yeah, one time I was at the, what's that thing called?
By the beach.
No, do you know the Guildhall where they put that thing on? No.
Oh yeah.
Gillow and Preston.
Yeah,
Yeah.
pantomime.
Oh yeah.
Oh.
And I've walked in on all these dwarves, all these 7 dwarves that are watching Snow White, and they all blew the horns at me, so I had to run out.
So did you,
I put his video.
They also, they put comic on
Is that good or?
Same as right.
They did comic on the Guildhall, but she was down.
Sometimes I'll
When I went, we got a picture.
And that whole thing.
sometimes I'll search up dwarves fighting. It's funny.
The wall.
Dwarves fighting.
There's one video.
This one.
There's two dwarves fighting.
Oh.
One of them keeps getting knocked over. So
You mean my people?
Yeah. So he has to. But one's like down, he has to wiggle to wall to climb back up.
What is me? I know. You know what Doctor Who is?
Yeah, he's my friend.
Which one?
So
Okay.
not everyone in the world.
Right.
Some of them are dead.
Okay. Right. Now you can wait. Right. So what you should have done now is obviously the bells for you guys are going to go in a few minutes. That is mitosis. Right. I will be asking somebody to relate that back to me. Right. So pack up your stuff, please. Right, Mohammed, trying to talk. You was trying to talk then. Right, Mohammed.
Oh, it's gone back on mute.
He wasn't on it.
Yes, sir.
You're right there.
Yeah. I'm going back to school tomorrow.
Back to school tomorrow. Right, that's good. We've got everybody's back.
Yeah.
Assalamualaikum.